Hello again, everybody. Now with the recording started, I will say a couple of words before we start with the content. My name is Lavinia, and I will be your moderator for today. We aim for interaction in our workshops and sharing experiences with each other. So if you have any questions, doubts, thoughts, own experiences, you can anytime post them in the chat, and we also have chat support to answer questions. And we will also moderate them on the audio during the talk. We have slots for questions in between, and we also will have time to answer questions in the end. So the more interaction, the better. And you can also post questions in German if that's more comfortable for you. That's no problem. We can translate them. We also want to improve our events further. And for that, of course, we need your feedback. So we will open a poll at the end of the meeting inside the Zoom. And the same poll will open up in the browser when you leave the meeting. So you can decide when you want to give feedback. And as I said, we would very much appreciate that. So that's enough of the organizational part. Let's say some words about us, the company, because not everybody here is knowing us already. We are CQSE, and we built the tool TeamScale, which you will see in this workshop in action as well. We were founded in 2009, originally being a spin-off of the Technical University of Munich, and that's still where our main office is. But as you can see, we're spread all over Germany. And if you are in Germany, it's likely that one of us is near to you. We also have an office in the US to serve our customers from Silicon Valley there. We have 67 full-time employees. 67 of them are software engineers, and over 20 of them have a PhD in software engineering, focusing software quality. So you can see software quality is our main topic, and that's also today's workshop's topic. And that software quality is important over domains and technologies. That's what you all show us today by being here. I've brought the logos of all companies that registered for today, and I think I don't have to add anything to that. So enough of me, and I'm very happy to have Tobias and Tobias here today as our speakers. And Tobias, the stage is yours.
Thank you so much, Lavinia, for the introduction. Hello, everyone, and welcome to this workshop. In this workshop, we want to show how development teams can ship high quality at any time. This requires that we keep the software we are developing at a high quality level, and we call an approach to achieve that continuous quality control, where the main idea is that we do quality assurance continuously already during development activities. Continuous quality control consists of 3 feedback loops, which we'll have a look at together: quality feedback for developers, for reviewers, and for whole development teams. And in our own development, but also at many customers where we introduce continuous quality control, we see a high benefit in terms of quality assurance or improvement, and also monetary-wise. But before we introduce continuous quality control, we want to introduce ourselves, that you know whom you are dealing with and from which context the experiences come that we share in the workshop. So my name is Tobias Röhm. I worked for several years as a freelance software developer, did a PhD at TU Munich, where I dealt with topics like problem comprehension and software quality. And I'm now for over 10 years a software quality consultant at CQSE, and I have the pleasure to, together with the CQSE colleague, work continuously with around 40 development teams, always with on the topics of measuring quality, making quality transparent, but also living processes that improve quality in everyday development life. And I'm very happy that we can share some of the experiences we made in that. And I hope that there are lots of interesting insights and best practices you can take from this workshop. And I'm also happy that I don't have to do that on my own, but that I have the support of a second Tobias.
Yeah, hi everybody. Warm welcome from my side as well. I'm the second CQSE Tobias in this talk today. Yeah, I did my master's thesis actually not in Munich, but in Paderborn here on software engineering. And the master's thesis was in cooperation with CQSE as well. So I started like 3.5 years ago at CQSE. And my context is mainly working with different development teams. So over time, I work with like 30 development teams or so, and mainly doing onboardings and coachings and quality retrospectives and so on. And my part today in this talk will be to give you some demonstration of how we can achieve all these three feedback loops using TeamScale. But before we do so, I think we should introduce some parts in these slides. So back to you, Tobias.
Thank you. I'm working now for 25 years in the software industry, and I think there have been quite some interesting developments in the last years. And I brought you some examples. The first one you see here, there is a hurricane occurring in Florida, and the car company Tesla wants to help all its customers that are in that area to drive away from that hurricane. Now it's important to know that a Tesla has a technical range he can go, but this is often limited by the software depending on the package a customer has bought. But now for that hurricane that is coming, Tesla wants to give all the customers in that area the full technically maximal range to drive away from the hurricane. And what they do to implement that is they release a new version of the software without the technical limitations in the software and push that via an over-the-air update to all the Teslas in that region. Second example is that a critical security vulnerability is detected in a library that is commonly used. One example would be the Log4Shell security vulnerability that was discovered a few years ago. And in that incident, we as a software development team obviously want to, as fast as possible, analyze if our software is vulnerable to that, and if it is, provide a new version of our software where the vulnerability is patched. These are two examples, but overall we observe a general trend with many customers we are working with that the release cycles are shortening over time, like where we maybe for a few years ago we released a new version of our software every quarter or every half year. Now the trend is going that we release new versions every week or every month actually. So what does it mean if we develop software in such a context and want to enable these scenarios? In our view, that means we must be able to release a new version of our software at any time, because we don't know when the next hurricane will come. We don't know when the next security vulnerability is detected. That might, on a first sight, sound like a topic for CI/CD or DevOps, but it also has a lot of implications for the quality or how we do quality in such a scenario, because in our experience, that means that the software quality must be in a release ready state at any time. We don't have time to do quality assurance when we want to release a new version, but we have to be done that already and just be able to release a new version of the software. And one more challenge which you might miss so far is obviously the question, what is the impact of using artificial intelligence in development on all that? And we want to look at a solution for these challenges, which we call continuous quality control and which is schematically depicted here. So the idea is that we do quality assurance not on a system level, as we might have done in the past, but on a ticket level. And a ticket might be a feature implementation or a bug fix or some maintenance work. And this is depicted here. Every box that is shown here represents a feature, a ticket. And what we do is that we already do quality assurance during development by using static code analysis, by using automated unit tests. And when we are done with implementing a ticket, then we look whether the ticket implementation fulfills all the quality requirements that we have. And then if a release comes, being a ad hoc release or a planned release, we include all the tickets or ticket implementations that are finished and fulfill our quality requirements, and all the others we move to the next release. That's the main idea. So we call that quality doors, and use usually a Git-based version control system, that every ticket is developed on a feature branch, and the pull request is the point in time when it's finished to check the quality as a quality door. And if we keep our main line at a release ready quality state and only merge tickets implementation, which also have release ready quality state, we can achieve this property of it having our quality at a release ready level at all time. So that's the main idea. How does that look in practice? We have found that such quality assurance activities can be nicely moduled as a feedback loop, and continuous quality control consists of 3 feedback loops that we see here. This is quality feedback for developers, quality feedback for reviewers, and quality feedback for the whole development teams. And that's what we want to have a look at now together. And at the end, look at the benefits continuous quality control brings and how it does interplay with artificial intelligence. The first quality or the first feedback loop is that we use static code analysis to support developers during programming, during working with code. And we give them a fast feedback that they can avoid bugs and quality deficits right from the start. I don't want to go deep into static code analysis here. I assume that most of you have seen that in the one or the other form. Just a few highlights that you know what we understand when we talk about static code analysis, what types of analysis we mean. One is detecting clones, copies of the same code in a code base. Another analysis is detecting bug patterns, code construct which might lead to production errors, like a missing null pointer check that might lead to a null pointer exception. Another analysis is static application security testing, like identifying potential security vulnerabilities like hard-coded passwords or injection attacks. Another analysis is identification of a bad code structure, which makes code difficult to understand and to test. And also on the architecture level, identifying mismatches between the implemented architecture and the architecture the architect had in mind when he was designing the system. And there are many more, as you might know, also violations of guidelines and so on. I think summarizingly, we can say that static code analysis creates transparency of the quality of a code base, what's the quality of the code and what's the quality of the architecture. And how a developer now can receive feedback and work with that during his everyday development work, Tobias shows us in a first demo.
Yeah, thank you, Tobias. So for this first demo part, I would now like to jump in the role of an actual developer of an actual project. So in this case, for this demo setup, I am now a developer of this digital bank project, or DigiBank project in short, which is a pretty basic and simple Java online banking application. And for the demo setup now, I have my repository in GitLab. Me as a developer, I have checked it out in my IDE, which is locally an IntelliJ. And both, so the GitLab server and the IDE is connected with the TeamScale server. In this case, the IDE has a plugin for that, and the TeamScale server directly speaks with the GitLab server here in this case. And now for the demo, the scenario is the following. I got a report from a user that there was a null pointer exception during usage of our software. And this user sent me a stack trace, and I saw directly, this null pointer flew in a file which is called account servers, and there in a method called credit transaction. And now I would like to fix. So first find the null pointer exception and then fix the null pointer exception using static code analysis here. So for that, let me quickly take over the screen here and let's jump into my IDE, so into the demo setup here. So now we are in IntelliJ here. I already checked out the digital bank repository and I'm already in this account service file. And I already created a branch here, which is this fix null pointer bug branch. And now I need to find this null pointer exception. And for that, I can go down to this credit transaction method here because I saw that in the stack trace. And if I scroll down a bit now, we can see that there are already some annotations here on the left side. And if I hover them, you can also see what those annotations are. In this case, this TeamScale plugin, which is connected to the server, communicated with the TeamScale server, and the TeamScale server already analyzed this method here, or this whole file, and sent back the analysis results. And in this case, we have two findings here. First of all, this variable account may contain a null value and it is dereferenced, so our null pointer. And on the other side, we also have a clone here, which means that there is copied code in two places in our code base here. So for our scenario, I would now like to fix this null pointer first because that's the most important thing here. And we see that account can be null because it is set to null here in this else branch. So for demo purposes now, I can simply remove this assignment here and replace it with an early return so that account can never be null here in this line after. If I hit Control S now, something will happen, which is both the findings are gone currently. So what happened here in the background is that TeamScale or this TeamScale plugin in the IDE on save sent my changes to the TeamScale server. The TeamScale server analyzed my changes, but only the changes that I did, and sent back the results to my IDE. So no analysis ran on my IDE here. So in this case, our null pointer and the clone finding are gone because obviously we removed this null assignment, and the clone code or cloned code is also removed because if we have the same copy in two places, then we change one place, then obviously it's not the cloned code anymore. So we fixed our finding, our null pointer here, and next step would be to use these quality doors that we just spoke about. And this would be to create a merge request in GitLab. And for that, I quickly need to push my changes to GitLab. I hit commit and push here very quickly. I disregard all the warnings here because they are coming from the demo setup. And then I pushed my changes to GitLab. And beforehand, I actually created a merge request so that we have a fixed merge request here in GitLab. And we see our commit just arrived, this fix NPE commit here. But we can also see another thing here, which is here in GitLab, we see that there is a new open thread. And if I scroll down a bit, you may have already seen it. You see that TeamScale, so the TeamScale server sent a comment or review comment to my changes here in the merge request, which is I found a potential inconsistent clone change in this account service file. Remember, we had this clone finding and we fixed the NPE within the clone. And now TeamScale tells me, do you want to change it in the other place as well? So what I would do now is I would like to have a look into the cloned code. And if I click here on View in TeamScale, then you will see the representation of this commit that I just did in TeamScale. And you see this alert here with this clone alert where I can now click on broken clone, which will tell me, this is the cloned code. So on the left side, there's one part of the clone, and on the other side, there's the sibling. And in yellow, you see my change, which is adding this early return here in this place. But now we see that on the other side here, on the left side, you see it's the same file, yes, but it's different lines, that there's still this null pointer. So in another space or in another place in our file, there's the same null pointer again. And Teamscale now told me, hey, yeah, if you do changes to a clone, our clone breaks, but you did not do the same changes to the other part of the clone as well. Do you want to do this? So it's kind of a warning here. And I would say as a developer, in this case, it's pretty obvious that we should do the same changes here in the other part as well, because we have a potential 9 pointer here as well. And that's exactly what I want to do next. So I close this view here and I jump back into my IDE. We remember that those were different lines, and those lines are not far away because it's simply the next method here, this debit transaction method. And here we have the same lines and the same null pointer finding in this place. And now, obviously, I can simply do the same fix here. I add my early return. But if I hit save now, you will see, yeah, the null pointer finding is gone, obviously, because I added this early return. But now we have a clone again, because if I change both sides of cloned code in the same way, we still have cloned code because the code is the same. But the problem with those clones is actually exactly what we saw now. If I do changes to one side of a clone, I need to remind myself to all the other clones of this, so the same code, and need to, yeah, think about whether I need to do the same changes in those different places again. And this can be a significant overhead over time, especially in large code bases. So what I want to do is to remove this clone to not having to, yeah, do the same changes all and over again for all the different clones. And for that, what one can do is basically extracting the cloned code, so the same code, into a common method. That's what I would do now. In this case, I looked it up before. I can simply copy everything between those debug statements here and use this extract method from IntelliJ. And now I can extract those lines to a new method. I call this method doTransaction because that's what's happening here. Hit enter and I add some braces here so that we do not run into a goto fail bug. And now I can replace the other side of the clone, so here in our credit transaction method, with the same call, like this. And if I hit save now, you will see that both the clones are gone, both the null pointer findings are gone, and now we have a pretty clean code at this point. And this is basically the end of my development here because, yeah, I removed everything that I wanted to remove, and I can again commit this to my merge request. So I push it. I need to select the file first and push it again to my merge request. This, and now we see I changed this line again. I know that I had or that I dealt with this clone. I had a look at this and I can resolve this thread here. So at this point, I'm pretty much done here. If I refresh, then you will see one more thing that is added to this merge request here, which is this Teamscale feedback in the top, where we can now see, yep, I removed 4 findings in this case, which are the 2 null pointer findings and the 2 clone findings. We had an alert here. This is, yeah, kind of important information for a future reviewer so that they can have a look at this if I fixed it correctly. But we can also see one new interesting thing here, which is this badge about so-called test gaps. So usually, if I do some changes like this, I would like to run some tests about them or on them. So in this case, in GitLab, I'd like to use some CI/CD to run some automatic test here. And that's exactly what I want to do now. So I go to my terminal here and I start some tests. So in the background now, there are some CI/CD tests running. And the results from those tests are uploaded to TeamScale so that it gets all the information about them. And if I hit refresh now, you will see that something changed, which is now we do not have those 3 test gaps, but we have only 1 test gap left. And if we scroll down a bit, you will also see that there are new comments, and those explain what those test gaps are. So if we scroll down here, you will see that there is a test gap. So this below is just a summary. We have a new test gap because this debit transaction method has not been tested. And what that actually means is that we did all these changes to 3 methods in this case, but one method of those was not tested after it has been changed. So if I click here on this badge, it's basically a visual link. We will see a visual representation of our merge request, and we see a visual representation of our changes here in this tree map. And each of those rectangles that you see now is representing one method, scaled by the amount of lines of code in the method. So in this case here, I'm already hovering this do transaction method where we extracted this whole code block into. This is why this rectangle is that large. And we see that this method is green. This means it was added or modified, and afterwards some tests was run on them. And we see that this credit transaction method was tested, but the debit transaction method was not tested. And this is kind of important for me as a developer because I can now add a new test to actually test this debit transaction method, because remember, we are in a digital bank context and this method is called debit transaction. I would assume that there should be some test for that so that we can fix it here or fix this test gap. So in the end, to summarize my workflow here, I got different feedback from TeamScale in different points of time during my development cycle. So first of all, during actual coding, so basically live feedback while coding in my IDE, then the feedback in my merge request on my code changes, and after I tested or after the CI/CD test run, also I got some feedback on my test gaps or how my test coverage changed. And these are 3 very important sort of automated feedback mechanisms that I, as a developer, can already use to fix my merge request before even sending that to some human reviewer who can have a second look at this. And this concludes this part of the demo. And without further ado, I would hand over back to Tobias to the slides.
Toby, we have one question concerning the demo, so let's take that one first. It's about the clone you removed. So the question is removing the clone more than the error message states, like doing 2 changes for 1 bug?
Yeah. So basically, in this case, this is for demo purposes. So I had a look before that we can actually remove or extract more than the actual clone into the second method. Usually, if you do this during live development, you would restrict yourself to the actual clone. This was just for demo purposes here at this place.
Good. I hope that answers the question. Otherwise, please shout. And then there's a second question on the feedback loops. And maybe it makes sense to take that one now. So we saw 1 loop for developers, 1 for reviewers, and 1 for the dev team.
I suggest that we move that. I'll take it in 4 slides when we are back in the feedback loops picture, actually, if that's okay with everybody. So I'd like to pick up where Tobias has left. So let's assume I have the head of a reviewer, and it's my task to review the ticket implementation that Tobias just showed what he has done. And I can use the feedback that already Tobias has shown in the demo here to get a first impression of the quality of the ticket implementation. So I can look here whether we have findings from static code analysis. I can look at the test caps to see how well the ticket implementation is tested. And based on that, I can decide whether I, as a human reviewer, whether I'm starting my review or whether I ask Tobias to improve the implementation of the ticket and the quality. And for us, we have the rule in our own development that a human review only starts when there are no findings from static code analysis and no open test gaps. And this allows human reviews to focus on the aspects that we cannot automatically check. I have brought an example here from a colleague where a colleague suggests to change the order of the parameters in a method signature to improve the understandability of the code of that method. So this is the second feedback loop targeted at the reviewers, which helps reviewers to efficiently do code reviews by two aspects. First one is automation, so the reviewer doesn't have to care about all the quality aspects that have already been checked by the analyses. And a second important factor that we often see is that when we do that, the developer is looking at this feedback as Tobias has shown and adheres to that. The ticket implementation already has a high quality, which makes it easier for me as a reviewer to understand the code and do a code review and saves time on that. And now is the point I'd like to pick up this other question about, I think it was about how to integrate unit tests results, or how a feedback loop could look like to integrate unit test results, acceptance test results here. I'd say that the feedback loops we are showing here are mainly targeted at developers and give developers feedback on their work. If we are talking about testers and integrating acceptance testing, I think, or we would integrate another feedback loop here, which we say feedback for testers, which provides then a feedback by the test gap analysis that we have seen. That, for example, the testers can have a look here, not at individual tickets, but at whole code bases with a test gap analysis, and see, for example, here, which parts are there parts of the code base that have been changed or implemented newly, but not tested during the acceptance test, and based on that decide whether they should do some more tests in the acceptance testing. Are there more questions on the two first feedback loops?
So no new question came up, but let's answer the one we had already. So there's one loop for developers, one for reviewers, and one for the dev team. The question was where the business acceptance testing is located here.
That's exactly what I just said, that we see that we would integrate, if that's interesting, to have a look at another feedback loop here for the testers, or for the testing, the people that do the testing based on the test gap analysis, and provide them with this information of what code that's here, a few of the whole code base. And we see everything in red is code that was newly created since the last release but not tested afterwards. Everything that's orange is code that was changed but not tested. And this would be an additional feedback loop for the testers, that they can have a look on that and see whether there are critical code regions that have not been tested in the acceptance test, and then decide whether they should do more tests in the acceptance test. This works for different different levels of the test pyramid, this feedback loop.
Okay, that's great. We have no more questions in the chat, so I think you can go on.
Thank you so much. Then I continue with the last feedback loop, which is feedback for the whole development teams. We have said a lot now, developers should do something, reviewers should do something, but obviously and usually they don't do that on their own, but we have to get them on board, to train them how to use the feedback mechanisms, also to get their input on the configuration of the analysis. And also what we see is to create a continuous awareness about quality, that this topic does not go away in the stressful everyday development activities. And another aspect is that we see that it's important to discuss in the team about quality to reach a common understanding of quality best practices. And in order to do that, we recommend a third feedback loop that we see here, where we implement a role that we call quality engineer, which is a person that periodically looks at the results of the quality analysis that we have seen and conducts periodically a so-called quality retrospective with the whole development team, meaning a workshop where about quality, where we are looking at the trends to create transparency and provide specific suggestions how the quality could be improved of that code base. And how a quality engineer might go about preparing such a retrospective, Tobias shows us now in a second demo.
Yeah, thank you. For this second demo part, we jump back to our digital bank project, and I'm still the developer of this digital bank project. But in addition to my developer role, I also got this technical quality engineer role. And my goal for the second demo will now be to create such a retrospective for the time being since our last release. So we have a next release coming up, and we want to have a look how our quality evolved over that time. And for that, I want to create such a meeting, so prepare such a meeting here. And to do so, I usually use 3 steps, or I think of 3 steps, which is first getting a generic overview or general overview by analyzing the trends, and then having a detailed look into all the new quality deficits or findings in this case. And afterwards, if I had a look at them, then I can create actual improvement suggestions, because I first need to understand what happened before giving some suggestions on what we can improve or how we can improve it. And if I prepared everything, so I had a look at all the data and I created those suggestions, I would also like to create a presentation that I then can take with me into the meeting with my development team. Such a meeting is usually somewhere between 60 and 90 minutes. So there's plenty of time to talk about things. And I would say, without further ado, before going too much into theory here, let's quickly create such a retrospective in team scale. So I will take over the screen again, and now you will see the team scale UI again. But now we are not anymore in our merge request, but we are in a space called quality control, namely here in this space retrospectives. And to begin with, I would like to create such a retrospective here. So what I would do is I create one. Now I can give it a name. We can leave it as it is now for this demo purpose. I need to select my project, of course. And I then need to set a specific start and an end date, because what we will do now is we analyze a time frame. In this case, everything what happened since our last release. So to start with, I would like to select our last release here. So I can select a baseline, and this is this release 2.1 here, and enter it. And the end date can simply be now or today. And now I can create this retrospective. And what we will see now is a starting page for this retrospective. And the first thing that jumps into the eye is this graph here in the middle, which tells me how, in gray, my lines of code developed over time, and in orange, how my number of findings developed over time. So you see this already. Of course, this is a very basic demo setup. In the real world, you will usually have much more or many more data points here in this graph, because you will have many more commits appearing in this time frame. But I think for this demo now, it's most important to get the point how you can use it here and how to get a clean or a quick overview over what happened. So in this case, we see that our lines of code dropped a little here in this commit, but we also see that our number of findings, so the quality deficits, increased over time. So in the end, we have more than before. so we have something to talk about in our planned retrospective meeting. So I now got a fairly general overview about what happened in this time frame, but I now want to have a detailed look into the actual findings, so into the new findings, which caused our increase here in this graph, in this orange graph. And what I can do now for that is to click on findings trend here, and then we have a delta of the findings for this time frame. In this case, we have 5 new findings. We resolved one finding. One finding was tolerated. This is this one here. And there are some of those blue findings or bluely marked findings. Those are findings that are in changed code, meaning there were findings, then the code was changed, and afterwards the findings are still there. But for this demo, we want to have a look into the new findings, so into the increase of the number of findings. And as we are on our master branch here, we see that we still have some findings here that are kind of familiar, which are these 2 null pointer findings here and these 2 clone findings that we saw in the first part of the demo. So what I would do now is to have a detailed look into all of those findings. So I could click on the finding here, and I could have a look, where is this finding, what is the actual problem of the finding, and so on. I will skip this here for time reasons, as we already saw what the actual problem is here. And in a real project or in a productive project, you would also have a much longer list of findings usually. So here you would have to do some prioritization because you won't have the time to look into everything in detail. So what I would do in that scenario would be to use the filter mechanisms here on the right side, for example, only looking into correctness or possible bug findings or security findings and so on. For this demo now, I would like to prepare everything, so prepare all the findings here. And if you remember, the second part or the second step of preparing such a retrospective is to create these improvement suggestions. And for that, what I want to do is I create so-called task and team scale. And I could show you what this is. So I mark these 2 null pointer findings here. And if I now right click and add to task and create a new task here, then you will see that we can create a task here in team scale. I can give it a subject, for example, fix NPN account service, because that's what we did in the first demo, right? I can assign someone, I can give it some tags, for example, report number 3, because we are actually creating the third retrospective here in this demo part. And then afterwards, I can also give some description here, which means I can give the actual improvement suggestion. So for the demo, I already prepared one, which I can simply copy and paste here. Usually when doing this on a live project, of course, I have to do some work here, going into detail into the different findings and create these suggestions. So this will take up some more time than today in our demo. And if I expand the 2 findings here below, you can see that those are actually these 2 null pointer findings that we had in our first demo part here. And if I now create this task, we will now have this work item here in team scale, which is basically a selection of findings together with a description on how to fix them. If I now jump back to our list of findings here, you will see, there are also those 2 clones. And as I said, I want to prepare all the findings for our presentation. But I know from the first part of our demo that these 2 clones can also be fixed when fixing the 2 null pointer findings. So what I can do now is I select those 2 findings as well and add them to the same task here, to this account service task. If I hit refresh now, you will see that all the relevant findings are added to a task. As I said, this one here was tolerant user. So we do not have to have a look into this in detail. So now if I look into my new task, I see, yeah, there are my clone findings, the null pointer findings, and yeah, the other clone finding here as well. And basically, now I'm done with steps 1 and 2. So we have all the clones, we have all the findings here in a task. Now let's jump to our third part or third step of our retrospective, or preparing the retrospective, which is actually creating a presentation. And for that, we jump back to our overview here. And you will also already see here in the top right that there is a button for that. So I could click here on create report for retrospective, but this will create an empty slide set basically where I can then add slides. But what I can also do is, remember, we're doing the third retrospective here, so the third report, I can simply select another report that I already did some month ago and take it as a template or use it as a template. So in this case, I click on this second report here. And what happens now is TeamScale copies the report, but fills all the slides with the updated data. So we see that the time is updated. So the analysis time, the time frame, and also all the other slides here, like, for example, the system quality overview slide is filled with new data, which is the updated data trends here, or metric trends in this base. So the only thing left for me to do is to add the task that we just created to this slide set as well. And I can simply do this by scrolling down a bit, because we see in the other report there was already a task, this task number 3, but I can already or simply replace it with the 4th or with the task with the ID 4. And now we see exactly the findings that we added to our task. So here we have our task, and here we have the 2 null pointer findings. And this way I could simply or very easily create a retrospective slide set that I can now take with me to our meeting with my development team. So I can simply hit start, and now I have a slide set to present to my team. And you see, if we scroll down here or scroll through our slide set, we have a lot of data to talk about, which was updated, but we can also have a look, for example, here in our code, in our findings, to have a very nice discussion. So the whole slide set here functions as a basis for discussion for my development team. And this is basically it. By doing this, we created this presentation. We are done with preparing our retrospective. And I would say this concludes the second part of the demo now. And I hand over back to Tobias.
Thank you so much, Tobias. I'd like to take one step back and reflect a little bit on what we have seen in the demo and what we usually do in the retrospectives. The first part is that we have seen that we are analyzing trends of quality, how the quality develops over time, being it in an aggregated fashion, as shown here on the left, where we see the number of lines of code in blue, how they develop over time, and the number of findings from static analysis in orange. And we also have seen that we can drill down a little bit in different aspects of quality, like correctness, like security, like clones. And overall, what do we achieve by that? We achieve that we create, transparency for the development team, and also for the management, if we include it here in the retrospectives, and also for clients, that they know how the quality develops over time, and if it deteriorates, to look more closely into that and do countermeasures to improve quality again. One explanation for this client, we sometimes have the constellation that we have a company who is contracting a software development provider for developing software for them, and this gives the client organization also transparency about the quality, how that develops over time. And the second thing we do is that we look at quality tasks that Tobias has shown us. Here are two other tasks. Details don't matter, but what that brings us is that we can now schedule quality improvements, that we have a list of tasks as quality improvements next to a list of feature requests, next to a list of bug reports. And when we plan our next sprint or our next release, we can schedule some of the quality improvements we want to do in the next sprint, for example. And also it helps teams that are not so experienced with quality as specific suggestions how to improve quality. And the second benefit that we see very often is that when we discuss about that, and it's important to say that the discussions here we do are very open so that everybody can bring in his view on the tasks, also on the quality topics that we look at, helps teams very much to create a common understanding of quality and of best practices for programming. And then it might be the case that different developers have different views on something, on how to do exception handling, for example, but then we discuss the pro and cons of different approaches in the retrospective and try to arrive at a conclusion and at a common best practice for the team that developers then can apply next time directly after the retrospective when they write new code, for example. So we have a shared learning curve about quality and about programming in the team by doing that. So that are the 3 feedback loops of continuous quality control. Now you might think it sounds quite interesting, but what does it bring? We have to invest here in a quality tool. We have to do retrospectives. What is the cost benefit of continuous quality control? And we hear that question sometimes more from the management side when we're starting with continuous quality control. And that's why we looked with several teams into this question. And I brought you a few examples about the benefits of continuous quality control that we have seen at customer teams. Here's one example of a C# team. We also see the trends that we have seen already. Blue are the number lines of code. Orange are the number of findings from static analysis. And we see that we have a proportional growth here. If we have more code, we also have more findings, which means usually that the quality assurance is not done or is not effective. And if we look at that closely, we see one point in time where the number of findings decreases. That was the point in time where we introduced the static code analysis tool with that team. We configured it. We trained the team to use that. On the meta level, we created awareness for quality. Some low-hanging fruits were addressed, but we see over time that we have the same trend as before, that when the stressful everyday development work comes again, so to speak, we still have the growth, the proportional growth. And that's what we found quite often. If we only use a static code analysis tool, we usually achieve only a short-term positive effect on quality. Obviously, that was not what we wanted to achieve. And also the leaders of the team didn't want to achieve. We wanted that the number of lines of code continues growing as the code base is extended, but the number of findings either stays the same or goes back and quality improves. And not surprisingly, this was one of the first teams where we did quality retrospectives. And I can show now how the trend continues. So we started with quality retrospectives with a team. Every vertical blue line here indicates a point in time where we did a quality retrospective, and we see that we now have the development that we want to achieve. The number of lines of code continues to grow, the number of findings decreases, and therefore quality improves. And that we have learned with many teams that the combination of the feedback from the tool and the discussions in the retrospectives has a lasting positive effect on quality. I brought you another trend from another team, but the idea is the same. I mark the trends here. Also here we see quite nicely the decoupling of the lines of code that keep growing and the number of findings which go back actually. What I find quite interesting to see here is that the decrease of the findings starts slowly and then increases over time, which is a common observation that it's really important to onboard the team by training, by configuring, and continuously do the 3 feedback loops that we have seen, and also the retrospective, and then that it takes some time for the team to pick it up, and then the effect increases over time. Another question that we hear is, how does that look like in euros or in person days, however you phrase that? And to answer that question, we did a study together with Munich Re, which is one of our customers, and thankfully we can show the results of that study here. We looked at one of this analysis, which is about clone detection, detecting copies of the same code in a code base and managing them. And clones have 2 negative aspects. The first negative aspect is if I have several copies of the same code in my code base and I fix a bug only in one copy and maybe don't even know that I have the same copy at another location, I only incompletely fix the bug only in one location and not in the other locations. That's what we have also seen in the first demo, this feedback of, hey, you changed one copy here, do you want to change the other copy also? And Munich Re is already for quite long using team scale and retrospectives, and therefore has very few clones and uses feedback from team scale to do clone management. And by that, they save around 500 person days per year above their or throughout their application portfolio, which they would have to invest in bug fixing the incomplete bugs otherwise. And a second bad consequence of clones is that if I do cross-cutting maintenance tasks, like we also have seen in the first demo, I have to do the same work multiple times if I have multiple copies of the same code, compared to if I have only one copy and no clones in a code base. And we found in the study that Munich Re saves 6% of their maintenance budget because of using clone detection and clone management to avoid redundancy. That might sound like a small number, but as this is a big multi-million development budget behind, it's also a big saving at that time. And that is only, from clone detection. We didn't talk here about bug pattern detection to avoid field failures or about SAST to avoid security vulnerabilities. So we see that continuous quality control also has a high monetary benefit in terms of savings. And I want to stress that these numbers are not hallucinated by us or by artificial intelligence, but it's the results of a really conservative, extensive study. And if you're interested in the calculation that is done and how it's done, I could recommend the workshop that is linked here on the slides, and I think also in the chat. So I'd like to finish the introduction of continuous quality control with 3 quotes from some customers of ours, which we thankfully can show here. The first one is from Christian Finkbeiner, who is a software architect at SEW, who said that if you want to achieve a sustainable logging quality improvement for a Chrome code base, it's not the analysis tool is important, but the process of using quality retrospectives. A second quote is from Erkin Barpisch, who is from VKB, who stresses the fact that when doing retrospectives, everybody is learning something about quality, about programming best practices by joining the retrospectives. And the third one is by Ben Weisheit from NetCBW, also a software architect who did such retrospectives himself in his team, and who observed that from the point in time when they started with this retrospectives, with discussions about quality, that the curves of lines of code and findings are detangled more and the quality improves. If you're interested in the details here, I've also linked them here on the slides, and I think we also see them in the chat. So are there any questions regarding the third feedback loop and the benefits of continuous quality control? That doesn't seem to be the case.
Sorry, Toby, it just lost the audio button. There are no questions in the chat, so I think you can continue.
Thank you. So I continue with the last part, and if there are questions, we can discuss them at the end or take them offline. I promise to come back to the topic of artificial intelligence and its influence and interplay with continuous quality control. I think all of us have seen a lot of claims and news on social media. Also, if you are attending conferences, you see a lot of talks about how artificial intelligence may or will change the future of how we develop software. And we looked into that, and I would like to look on the combination of continuous quality control and artificial intelligence from two angles. The first angle is, can we use artificial intelligence to do continuous quality control, to support us? And to study that questions, we did several studies in cooperation with TU Munich. And I brought the results of one of these here and would like to show that. So what we did here is that we use artificial intelligence as a code reviewer. We have seen that code review is important feedback loop in continuous quality control, and human time is very rare, and so automating code reviews is one goal that we want to achieve, and that we did with static analysis. So the question is, can we use artificial intelligence to automate code reviews further? So what we did is we implemented an LLM-based code reviewer who got pull requests exactly as we have seen. So we use pull requests from our own development, from the team scale development, which contain some change files, which contain the ticket description, and which contains the programming guidelines for the team scale development. We gave that to an LLM and asked it to do code review and to analyze the code and suggest how the code should be improved. Then we got between 3 and 20 review comments for one pull request, and then we gave those review comments to the developers that originally created the pull request and asked them, please rate, is that helpful feedback? Would you do what the LLM suggests here, or is that garbage and you would ignore what the LLM suggests here? And we got very nice results. Around 40% of the review comments were rated helpful by the developers. Also, the LLM found the same bugs as a human reviewer had found, and some developers also started revising their code based on the feedback they got from the artificial intelligence. But also, on the other hand, 40% of the review comments were rated as useless by the developers because it didn't really address a quality deficit, or it was such a nitpick that they said it's not worth to act on that feedback. So the result was mixed. Actually, sometimes really great, helpful review comments, sometimes useless review comments. And that is very in line with our impression also from other studies. If you're interested in that, I can show them later. I won't show them here now in the talk. Our impression is that AI is a great support for developers, but no replacement. Some of the AI approaches and results are really impressive, but not good enough, or not good enough yet for automatic deployment. And we need a human in the loop to do this discrimination. When is what the AI suggests, when it is correct and good to do, and when is it incorrect and should be ignored? Which means that we have to balance the cost, like the human effort we spend to do this discrimination with the benefits we get from artificial intelligence. To make this a little bit more specific, how can we use AI within continuous quality control? So the one thing we just saw in the study is that we could use AI for doing code review. Obviously not left alone on its own. We still need an experienced developer to review the comments by the AI, but as doing part of the code review. And the second aspect we look at is to provide fix suggestions to developers. So whenever we have a finding from static analysis, ask an LLM how the code should be refactored to address the quality deficit that was identified by the findings, and therefore helping developers to improve the code faster. I'd like to look from a second aspect on continuous quality and AI, and that is if we assume we have more and more, or we use more and more artificial intelligence in development and programming, however you call that, if you call that agentic coding, if you call that vibe coding, if you call that pair programming between a human and an artificial intelligence, how about the quality assurance of the code that is either generated by an AI or developed in assistant by AI? And can we use continuous quality control for that purpose? And an important question for that is, in our opinion, is how good is the code that comes from AI, that is AI generated? Do we actually have to assure the quality there? And in our experience, it's good to discriminate here what kind of software we are developing. If we are doing a prototype or a single script that we use once, or if we are developing mission critical software that controls a plane or runs a whole company or something. And we have the impression that often when we talk about artificial intelligence, many of the blog articles and news focus on the left-hand side, where quality isn't so important. If I do a prototype just to try something out, I don't have to do quality assurance at all. But when I'm developing a mission-critical software system, obviously quality is a very important topic and should be assured. And we see that we have the same quality requirements for mission-critical code, no matter if it's developed by a human or by an artificial intelligence. Something like functional suitability, that tickets are implemented correctly and completely, that we have no bugs, that we have no security vulnerabilities which attacker could possibly exploit. Also, that we have maintainable code where I, as a human, can understand and check what the AI generated here. And there are, I think all of you know these usual quality requirements, and also that we have established methods of assuring or detecting whether those are fulfilled or not, like static code analysis, like code reviews, like tests. And also these are, as we have seen, components of continuous quality control. So we can use continuous quality control for doing quality assurance for AI generated code. And I'd like to point that out, how that could look like in detail. We could use the quality door approach that we have seen to avoid that AI generated code with bad quality comes in our code bases. We can use a static code analysis to scan also large amounts of AI generated code to get a feeling of the or to analyze the quality of that code. And we can also integrate that via an MCP server, for example, into an agentic coding agent. So the idea here would be that whenever an agentic coding agent generates code, he is instructed automatically to run static analysis on that code and fix the findings that have been found by static analysis, and thereby increase the quality of the code that the AI has generated. We can use code reviews, as we have seen, obviously also for AI-generated code, and we can use retrospectives to discuss in the development team of best practices how AI can be used in development and also how to ensure a high quality when using artificial intelligence in development. If you're interested in that, I'm very happy also to show some more details and studies we did either at the end of this talk or afterwards.
Toby, we have one question
Sure.
concerning AI.
That's perfect.
The question is, who writes the unit tests for AI-generated code? Hopefully not itself.
That's a good question. I think there are two approaches. One is also have AI to write the unit tests if the quality of the unit test is good enough. The other approach is to do that that the human is doing that. I think we are also looking into whether we can automate writing unit tests using AI. I think to me it's not. There's no fixed approach saying do it like that or doing like that, but it's important to have unit tests and to ensure that they have a good or a high quality, no matter whether they are written by a human or by the artificial intelligence. But I think there's potential that AI can help to write unit tests, to have more unit tests or write unit tests faster.
Thank you.
To summarize, we have seen that in today's world, we have to be able to release a new version of our software at any time. And that means we have to do quality assurance continuously to have our software at a quality level or at a release level quality state at all times. We have seen the continuous quality control that enables this property by having the 3 feedback loops for developers already during programming and coding, feedback for reviewers to automate reviews as fast as possible and ensure high quality of reviewed code, and for the whole development team to configure the analysis, to get everybody on board and to create a common understanding of quality. We have also seen that continuous quality control has a high benefit of either doing quality assurance, keeping a code base clean from the start, or improving the quality of a grown software. This also translates in big monetary benefits of euros or time savings. And we have seen that we can use continuous quality control to do quality assurance when we use artificial intelligence in development. So much what we wanted to show here. Thanks for listening. And we have a lot of experiences in introducing continuous quality control from our customers. So if you think that sounds interesting, I would like to try that out, or in your team, we are happy to help. Please get in contact with us either now or after the workshop. Also, if you say would like to discuss more, then now is the time for that, or also after the workshop. Thank you very much.
Okay, thank you so much, Toby and Toby, for the workshop today. I'll take over the screen for some additional points at the end. So can you see my...
Yes, we can see the screen.
That's great. So thanks again for everybody for participating today and also for asking questions and sharing your thoughts. As announced before, we will start the feedback poll now, and we would really much appreciate your feedback on the workshop today. And so the poll is just popping up in this Zoom meeting, but it will also open up in the browser when you leave the meeting. So you can either fill it out now or in a couple of minutes. Then, as we said before, we will send you the slides and also include all the links of the articles and workshops that were mentioned today, so you don't have to Google anything of this. And more than that, we also have more live workshops coming up. So the first one is in about 2 weeks, also with Toby as speaker, and he will talk about security and static application security testing. This talk will be in German, and we will have another English one in June with Sven Amman, sorry, where we will share 3 secret ingredients for successful software engineering and keeping quality high. So that's it from our side. If there are any questions left, we will stay here and answer them for a couple of more minutes.
Are there any questions right now or wild discussions about AI? I'm now reading this discussion about who writes the tests for AI actually in the code. I'd like to who writes the unit test for AI generated code, and I'd like to stress this fact. I think that's important to have a test, and we are experimenting, and our developers say it helps to use AI there, but it's important to review the test and make sure that the test has a high quality, and then we have a reproducible quality measure, so to speak.
It's better for me to talk here.
Yeah, sure.
On this topic, it's from me. I think it's also a good idea to have the AI read the specification, another AI, if it's important, reading the specification and writing the unit tests and review these two together by a human, because if you have a perfect specification, a perfect unit test, you can also do something else to prove that the code is doing what the specification says. There is a mathematical doing so, but I think this is very sophisticated, and there is no automation tool for that. But a proof code,
I think at least in the general space, I think it's possible for some
yes,
contexts which are not so complex, right?
I know that. I know that. This is really important because you have to do pre and post conditions for each function and so on. Then you can formal proof.
Yeah, exactly.
Of functional code. Special case, but this is better than unit testing, and unit testing is better than review because unit testing specifies what the code does, but not where the errors are. Okay, my point of worth.
And I think one thing you point out there, if you have a perfect specification, this would work or make it easier. Often it's not the case that you have a perfect specification, at least. It's also important to ensure the quality of the specification, so to speak, where we are.
But my point here is the AI is mostly LLMs, so large language modules, and
exactly, yeah,
perfectly good with verbal language, associative things, not so good with mathematics of code. And I think it's a really good idea to use the AI to write a good, well, not at least a perfect specification, or to improve the specification. This is where the AI is more useful than in writing code from a bad specification.
But check the quality of the AI written specification afterwards.
Yep. Right, but I think the AI is not perfect. It should be treated like a normal trained human developer or architect, and it makes mistakes, and we have to discuss and clarify things together. Then it could work if the AI evolves accordingly. If not, the hype is over soon.
Yeah.
We have one more question in the chat on clone detection. So is clone detection done via one-to-one comparison by the letters or additionally based on code semantics?
It's mainly based on code semantics. So we do not track all the letters in the code, but we compare actually the structure of the code. So for example, if you have different identifiers or so, those will not count into the clone detection. But you can also do some more configuration stuff on the clone detection. For example, configuring how long a clone has to be until there's a clone finding, or actually allowing some gaps. So for example, you have code, which is the same, but in between, so somewhere in between, there's something different. Then you can also allow the clone detection to allow those gaps in those clones and actually detect the clone anyways. So there's much to configure there, and it's not based on the letters. So it's not a one-to-one comparison here.
Then I think we can end the workshop and say thank you again to everybody who joined today and asked questions, and to our speakers. And have a nice lunch break, and see you soon.